Welcome back to The Explainer. So, if you work in a multi-story office building, you probably take the elevator every single day without giving it a second thought, right? I mean, it's a total marvel of modern engineering. But today, we're going to look closely at the hidden mechanics behind your daily commute, and specifically what actually happens inside the walls of your building when things go terribly wrong. Okay, let's dive into this. We've all seen it a million times. That ubiquitous little red and white placard bolted to the wall right next to the call button. In case of fire, use stairs. But have you ever actually stopped to wonder why? Like, why does our absolute fastest, most efficient modern convenience suddenly become a deadly trap the very second an emergency strikes? Well, as you'll see, it's not just some friendly suggestion from building management. It's a strict rule built on top of some truly fascinating and honestly kind of terrifying engineering realities. So let's break this down into phases. We are starting with phase one, the logistics failure. Because the truth is, just evacuating a massive office building is a totally complex, multi-level mathematical challenge all on its own.
Even before we get to the actual smoke and fire, you have to realize that this is a total logistical nightmare. Picture this. The alarm goes off. A huge group of people on the top floor piles into the elevator, filling that car completely to the absolute max capacity. But down below, you've got dozens of unaware people frantically pressing the call button on their own floors. So as that packed elevator moves down, it's mechanically obligated to answer those calls. It hits the 15th floor, the doors open, and no way, nobody can fit. The door slide closed, then it drops to the 14th floor, doors open, doors close. It literally does this uselessly on the entire agonizing way down. The sheer amount of time it takes to get just one single group to the ground floor is absolutely monumental. It's a complete bottleneck.
So it's dangerously slow. But from that slow logistical failure, we immediately move to a terrifying mechanical danger. This is phase two, electronic betrayal. Now, what's really interesting about this slide is how the building's own technology basically turns against you. You see, modern elevators are controlled by highly complex electronics, and the extreme heat generated by a serious building fire doesn't just burn things up, it actually melts the internal wiring. That intense, localized heat can quite literally cause the elevator's call buttons on the burning floor to short circuit entirely. And that leads to the short circuit effect. Imagine you're desperately trying to escape in that lift. Your intended path is heading safely down to floor 0, right? Getting out of the building. But because the fire on, let's say, the 8th floor has melted and short-circuited that specific call button, your elevator's computer registers a phantom request to stop there. The actual result? Your lift stops, the doors open, and it gets stuck directly on the floor with the fire. It literally drags you to the absolute worst possible place in the entire building. And look, if the electronics don't fail you, the hidden architecture and physics of the building just might. We are moving to phase 3, deadly physics. The next time you look at those metal doors in your lobby, I want you to remember that it's not just a transport tube. It is a massive, completely empty vertical shaft running the entire height of the structure. And that creates a highly critical danger known as the chimney effect. It's exactly what it sounds like, the natural tendency of an elevator shaft to mimic a chimney shape, rapidly drawing up and filling with smoke. Because it's this giant vertical void, it creates an incredibly powerful draft. As the fire breathes, that elevator shaft basically acts as its exhaust pipe, pulling all that danger straight up at terrifying speeds. And we really need to understand that the smoke rapidly filling up that shaft isn't just some harmless, cloudy byproduct that just makes it a little hard to see. It's a highly complex, deadly mixture. It carries a massive amount of heat, it contains incredibly toxic gases, and it is absolutely packed with harmful fine particles that immediately attack your respiratory system. Being trapped inside an elevator car, inside a shaft experiencing this chimney effect, means you're basically sitting in a locked box that is rapidly filling with a superheated, toxic fog. But even if you manage to risk the slow logistics, the short circuits, and the chimney physics, there is still one more absolutely massive reason you need to stay out of those cars. Phase 4.
Hijacking rescue operations. Let's move to and see how this builds.
We need to totally flip our perspective here to the emergency personnel. 10. That is a critical number. If a fire is located above the 10th floor of an office building, firefighters absolutely 100% rely on elevators to do their job. I mean, lugging hundreds of pounds of heavy gear up a dozen flights of stairs would completely exhaust a crew before they even reach the blaze.
So this creates a massive conflict of resources. On one side, you have civilians trying to take the elevator down to escape. But on the exact same side, you have the firefighters' absolute need to use that exact same elevator to move their heavy personnel and equipment upward. If you are occupying those cars during an active fire, you are directly taking a highly valuable, life-saving resource away from the exact people who are equipped to save your building.
Let's actually look a little closer at their specific logistics. Firefighters don't just ride an elevator right into the flames. That'd be crazy. They establish a command post, which is usually located about 2 levels below the active fire. This crucial 2-floor buffer zone is where they stage their counterattack, get their equipment ready, and prepare to push forward. To set this up fast, they trigger Phase 1 recall. It's an emergency override key that cancels all civilian floor requests and forces the elevators directly down to the ground floor so the fire crews can lock them out and take manual control. If you try to bypass this and use the system anyway, you are creating a terrifying reality. Official safety guidelines spell it out. It takes their attention and efforts away from their role in putting out the fire. Think about it. If you use the elevator and the fire spreads and engulfs that shaft, you're trapped. Suddenly, instead of actually extinguishing the blaze and saving the rest of the building, those firefighters are forced to drop everything and pivot into an incredibly difficult, dangerous rescue scenario just to save you. You've actively hindered the entire effort to stop the fire. So, the logistical nightmares, the electronic failures, the deadly physics, and the hijacked rescue operations, they all bring us to our final section, the ultimate safety choice. It's elegantly simple, honestly. The emergency fire escape stairs are designed precisely so you don't have to take those risks. The stairs aren't just some inconvenient backup option. They are a calculated, heavily engineered safe zone. They are structurally designed to completely bypass every single one of those cascading elevator failures we just talked about. The entire architecture of the building accounts for your safety, provided you stick to the stairs. So, I have to ask, tomorrow morning, when you walk into your lobby with your coffee to start your workday, will you look at your office's metal elevator doors the exact same way? Behind them is an absolutely remarkable piece of modern engineering, but it's one that fundamentally transforms into a major liability during a crisis. Understanding these hidden mechanics ensures that the next time those alarms ring, you'll know exactly why the stairs are your best and, really, your only choice. Stay curious, stay safe out there, and I will see you on the next explainer.